Okay, so we're starting with this ideal gas law. P1 V1 over T1, P1 V1 over T1 is equal to P2 V2 over T2. Okay, that's our ideal gas law. Now, in your book, I'm looking on page 175. There's an example here. You take an empty tin, and put a lid on tightly. We heat it with a Bunsen burner until the air inside is 50 degrees C. What is the pressure inside the tin? The temperature of the room is 20 degrees C. Okay, so what we need to know is that, first of all, the volume is a constant. It's just a tin. It's a fixed volume. So at a fixed volume, the volume does not change. Volume 1 equals volume 2. Okay? So, in other words, P1 V1 over T1 equals P2 V1 over T2. So I can cancel out the volumes. So I have just got P1 over T1 is equal to P2 over T2. Okay? So we're actually looking here at a constant volume. This is a bit like this one we've done. Okay? That the pressure is proportional to the temperature. Okay? Pressure is proportional to temperature. If I were to rearrange this a little bit, we'd have got we can get it to show that the pressure is proportional to the temperature. Okay. Anyway, this is the equation that we need from the ideal gas law. Now we are told that it starts at 20 degrees C. So at 20 degrees C is our initial temperature. Okay. And we are told that we heat it up to the second temperature is 50 degrees C. These are not in absolute temperature. We need to have it in Kelvin. Okay, so we need to write this in Kelvin. Now remember that I told you that the temperature in degrees C is equal to the temperature in Kelvin minus 273. So actually we want to find the temperature in Kelvin. So T1 is actually going to be the temperature in degrees C plus 273.15. 20 plus 273.15 Kelvin. Okay, so in other words, 293.15 Kelvin. And T2 is going to be 50 plus 273.15 Kelvin, okay, which is 323.15 Kelvin. Okay, so we've changed this into the right unit now. Now the other thing we need to know is the pressure at the start, P1. Now the pressure at the start is, we're told that it's just in a room with air. So we need to know the atmospheric pressure. Okay, now we know that the atmospheric pressure is actually 10 to the 5 pascals, or 100 kilopascals. Okay, so that's our P1. So we've got P1, we've got T1, P1 and T1, we've got T2, we just need to find P2. So we take this equation, P1 over T1 equals P2 over T2, and we rearrange it to find P2. P2 is equal to P1 times T2 over T1. So we've got 10 to the 5 times 323.15 divided by the initial temperature, which is 293.15. Okay, so we need our calculators to work that out. Get my calculator. So we've got 1 times 10 to the 5 times 323.15 divided by 293.15, and we get our answer as 110,233. Okay, which is 110,000 pascals, okay, which is 110 kilopascals. So that's our answer, okay, which is the same as the example in the book. So with these examples, you start off with the ideal gas law and you work out what is fixed, in this case, a fixed volume. So we can just scrub out the volume, and then we just end up with this gas law here, which was what I called the pressure law. Okay, and then you use the pressure law. You have to turn your temperatures into Kelvin. Temperatures must be in Kelvin. Okay, temperatures must be in Kelvin for using the pressure law. It's got to come down to 0. It's got to be directly proportional. Okay, and then we just substitute in the numbers and we get the answer. Okay, thank you.